Software Engineering Radio, episode 134, interview with Michael Nygard.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support. Welcome, listeners, to another episode of Software Engineering Radio. This is, I think, interview number 6 recorded at this year's JAU. And we're going to talk about a book that's actually, it has something in common with another book we talked about. It's the second book on software I've seen which has a glider on the cover. And of course, I think that's because the book is called Release It. And of course, the glider has a release handle to release the towing cable. And our guest, of course, is the author of this book, Michael Nygard. Hi, Michael.
Hi, I'm very glad to be here.
I'm glad we can get you on. Well, the obvious first question, please talk about yourself so our audience knows who you are.
Sure. I'm an architect and developer of application software. Have been for nearly 20 years at this point. I've done work in many different domains: military, scientific, engineering, industrial, education, finance, and for the last 10 years or so, a lot of retail work. Mm-hmm. Through a somewhat bizarre set of circumstances, about 5 years ago, I ended up moving into a group that does operations for software that we didn't write.
Right.
So while I've always followed my own software into production, now I get to take accountability for software produced by other people as well.
So you feel the pain.
Absolutely.
Yeah. So this is already a little bit of an introduction how you came to write this book. So please give us an overview of what the book is about. Many people might probably know it. Actually, we got requests to specifically get you on the show, so at least those people know the book.
Oh,
please,
fantastic.
Yeah, please give us a 10,000 feet overview of what the book contains and how you came to write it.
Well, what I learned receiving software into production and being the person who gets called at 3 a.m. when it doesn't work, what I learned is that the software we tend to produce isn't all that well suited for living in the real world. Mm-hmm. The world of production is where it ultimately matters. And I came to believe that all of our material on design and architecture, all of that is aimed at the moment of passing QA. It's aimed at getting the functional requirements right, but it isn't aimed at surviving in production. And to me, this seemed analogous to the aiming for the birth of a baby while making no preparation for that child's life as a human being after the moment of birth.
Mm-hmm. Yeah. So then the book is about how to write software in a way that the operations guys are happy. Is that a fair assumption, or is that a little bit too small a scope?
That's definitely one way to read it, yeah. But it's not just the operations guys, of course. Our sponsors, the people who pay for our software, are really much more interested in how it does in production than how well it passes QA. Mm-hmm. You can pass QA on your first regression test with flying colors, and ultimately no one will care if it doesn't run in production.
Mm-hmm. Okay, so I guess, going down from 10,000 feet to, let's say, 7,000 feet, if we look at the structure of the book and hence at the structure of this topic at the overall problem space, is there a way to structure it, in a couple of sections that we might then discuss in the rest of the podcast?
Yeah, I built the book in sort of priority order of trying to deal with the worst problems first. Hence, the first part of the book is all about stability. Because if your software is not stable in production, then it doesn't matter how well it performs, and it doesn't matter how well it can be changed in the future. Yep. So the first section of the book is about stability. And in each of these sections, I introduce with a case study. I've been told that these read like detective stories, which was kind of what I had in mind, that these should be, first-person, real-life examples of things that happened at actual companies. Yep. Though I've disguised all the names.
Sure.
For obvious reasons.
Yep. And then the other aspects are just to give an overview of what's coming in the rest of the episode. After stability, we have
a section on capacity. because once you've stabilized your system, the next most common complaint I've observed is that it doesn't perform well enough, or it can't handle enough concurrent users. So stability, again, I introduce with a case study, and then I have a number of anti-patterns, common things that I see people doing to harm their capacity, and then patterns that you can apply to improve capacity, even on the infrastructure you've got.
Right. Okay.
So I'm not specifically addressing scalability, which would be the ability to add more resources.
Right.
But I am addressing maximizing the value of the resources you have.
And section 3 is then, I guess, stuff you can put into the system to really make the operations guys happy so they can monitor the system and understand what's going on.
Right. Yeah, exactly. I found a lot of the software that we were receiving into operations exhibited what I called sick goldfish syndrome. When you have a sick goldfish, it's going to live or it's going to die, but there's bugger all you can do about it in the meantime. You just wait to see if it goes belly up. We have to put in the ability to know what's going on inside the system. And so that's what that part is about.
Okay.
I also talk about how to build it so that operators don't inadvertently make mistakes and do bad things to you.
Okay, so let's look at the first of those, stability. And I guess it's a good idea to first define what you mean by the term.
I view stability as the consistent, long-term availability of the features that your users care about.
Okay.
So I approach everything with the assumption that your users don't actually care whether the server's up and running. I've tried to explain about deadlocks and hung threads and how the Java virtual machine is still running, but it's just not doing anything because all the locks are held. That argument never really seems to work. They still keep saying that the site has crashed.
Right.
Because to all externally observable behavior, it is crashed. And so, but I also want to take the perspective that sometimes you will have partial functionality available. We build complex systems with integration out to, significant portions of the internet and other parts of the enterprise in any, reasonably sized company. And so it's very often the case that some computer somewhere is malfunctioning, and therefore I can't do the normal function of my application. But I may be able to preserve partial functionality and serve some users well.
Graceful degradation, right?
Absolutely.
Yeah. And I guess also the other thing is that usually one failure is typically not enough. You have to typically, chains of failures or a couple of, bad circumstances happening at the same time, and that brings down the overall system. So understanding those chains and those dependencies is probably also an important aspect.
It is, although usually you can only identify those chains in retrospect as a post-mortem.
Yes, absolutely.
And they always seem perfectly obvious then, but, of course, very difficult to predict. The state space is so large, and every external integration adds new dimensions to the state space. Yeah.
Which brings us to the first of the anti-patterns, i.e. Things you can do wrong. You do them right in the sense that whatever. If you do these things, the chances for stability are lower. So that's the definition of what the anti-patterns are. Can you give us a little bit an overview of what some of those are? Maybe the, top 3 or 4, and maybe help us understand some of those?
Sure. Well, the first anti-pattern that I talk about and what I consider the number one risk to stability is integration points. I think our systems would be much happier if they didn't have to integrate with any other systems. Yeah. But of course, a standalone program isn't very interesting these days. Yeah. So, in a sense, integration points are a necessary evil. Yeah. But I want everybody to regard them as inherently dangerous to the stability of our own software. And so I go through a number of examples and cases where even seemingly innocuous things like database calls can cause our application to hang. Beyond the textbook deadly embrace.
Right. Yeah. Can you give us an example of one of those? I mean, how does a database query, relate or result in such a problem?
Well, you can have a situation I call a cross-tier deadlock. So because we're dealing with multiple threads, we always have to consider that. In a cross-tier deadlock, one thread is holding a lock on a row in the database and needs a connection from a connection pool. the second connection pool is likely exhausted, and perhaps one of the threads that holds a connection in that pool could release it if only it could get a lock on that row in the database. So we have one thread which is blocked in the application tier and another one which is blocked in the database tier. There's no server in the world that will detect that.
Right. Okay.
So the easy way out of that one is if you only ever have to have one connection pool and you're only ever speaking to one database.
Yeah.
Again, that's sort of a tough constraint to meet these days.
Yeah, yeah. The other anti-pattern I found actually quite funny is users.
Well, users are very harmful to a system.
Yeah, I detected that already before. So
unfortunately, like integration points, they're also necessary. A couple of ways that users can cause problems. It's not so much individual users who cause problems, but it's the masses of them. So we had this term, the slash dot effect, from the late 90s. But these days, the slash dot effect is a trivial bump. The real dangerous sites are ones, CNN.com.
Yep.
Anything that goes on CNN.com is very likely to crash.
To die,
because stories go up at a moment in time. And so large numbers of people find out about the site at a moment in time. And pretty much all of our applications and application servers deal badly with getting too many users approaching the site at once.
Yep. Yeah. So huge amounts of users are the actual problem, not users themselves.
Right.
Okay. So another one, maybe the last one that sounds really interesting and kind of non-obvious, is the SLA inversion. SLA standing for Service Level Agreement.
Yes.
What's that about?
So SLAs are hugely important to IT operations. They're usually, if internal to the company, they're evaluated on their ability to deliver SLAs. The executives are, called on the carpet if they're not delivering the correct SLAs. And so we often are asked to make promises with really no way to back them up.
Right, yeah.
SLA inversion is an anti-pattern that occurs when a system is expected to deliver a very high SLA, and yet it has dependencies on other systems of lesser SLAs.
Okay.
And even if it has dependencies on other systems of the same SLA, because we expect failures in those dependent systems to be uncorrelated, our SLA would be not just the minimum of our dependent set, but our SLA would actually be the product of the SLAs of all of our dependent sets.
Yeah.
So when you take a look at a system with a typical number of integrations and dependencies, you can easily get your SLA down to 92, 90, 88% very quickly. Particularly, we also often have hidden dependencies on things like enterprise services, such as LDAP or DNS.
Right. Yeah.
These are not normally sort of accounted for when we're drawing our architecture diagrams. They're just the substrate of the network.
Yeah.
And they also tend to be handled badly by IT. DNS servers are often, Spark 20 pizza boxes sitting under the network admin's desk.
Yeah. We talked a little bit about the anti-patterns, which is stuff you shouldn't do. I guess you could argue that it's more important to understand the stuff you should do. So let's look a little bit at some of the patterns.
Sure. So first, I do want to say, though, that I think there's a lot of value in understanding where the problems lie. And even just knowing about them helps you avoid some of the issues.
Yeah.
The stability patterns are solutions that I've seen that address classes of problems. So one of them that I think is particularly significant is what I call the circuit breaker pattern. This is a component inside of an application that counts failures, perhaps using something like a leaky bucket counter.
Yeah, and we talked about that in the Bob Hanmer episode, so you might want to go back and listen to that.
So if the circuit breaker counts too many failures in an integration point for a given unit of time, it cuts off that feature.
Right.
I believe that this is a better way of approaching failures in integrations than the typical sort of retry loop. If you think about a retry loop, if you're calling a back-end system that's degraded, you're timing out. And a retry loop just means you're going to incur multiple timeouts.
Right.
Which hurts your system because it means you're now responding slowly to your users. So somebody else's problem is becoming your problem.
Yeah.
And it hurts the back-end system. We already postulated that it's degraded. And so when it's degraded is exactly when we're going to hit it even harder, which doesn't really make sense.
Yeah.
Instead, the circuit breaker attempts to understand the global state and cut off that call when it's not going to succeed.
Mm-hmm. Right. Just give up, basically, and forget about that part of the
For a
functionality.
while.
Yeah, for a while. Yeah, okay. Timeouts are obviously related, right? You should never try to talk to any other system without giving it a time limit.
This is something I see everywhere.
Yeah.
It's almost painful how many places we write code that can block forever.
Yeah.
Of course, we have the obvious things like socket communication, where we use blocking reads and writes. And all it would take is one function call on the socket itself to set SO timeout.
Yep.
And you could avoid having reads and writes blocked forever without incurring the complexity of NIO.
Yep. Yep.
But then we also see things like checking out resources from a resource pool is usually done with no timeout. I think this is always a bad idea. You should set a timeout on your resource pools and have the application code be prepared to receive a null response when there's no connection available.
Right. Makes your code a little bit more complex because you have to handle the null, but I guess that's what it takes to build stable systems.
Exactly. Exactly right.
Yeah. Bulkheads, what's that? I know the term from aviation, so that's why I'm asking.
I'm using it in the nautical sense. The bulkhead being a partition that prevents flooding in one compartment from causing flooding in another compartment. So generally speaking, bulkheads are about partitioning a system for stability. We've had a lot of talk recently about horizontal partitioning for scalability.
Yep.
But in this case, what I'm really saying is, if I accept that damage will happen and bad things are going to occur to my system, what I really want to do is make sure that bad things can occur in one part of it while I maintain service for the rest of the rest of the system.
Yeah.
And I think this is particularly important for anyone who's building a common services or a shared services component in an SOA or just as an enterprise service, because ultimately everything will be operationally and functionally coupled to that shared service. So any downtime or lack of availability in that shared service has a ripple effect throughout the enterprise.
Yeah. And finally, the last one I kind of don't really know what it means is this decoupling middleware stuff. I mean, sure, I know what middleware is and I know what decoupling is all about, but what do you mean in this context?
Well, decoupling middleware, it's essentially a rant which says most of the problems that I've described throughout this section are due to our use of synchronous request and response type semantics.
Yeah.
So decoupling middleware is an argument for messaging, tuple spaces, and essentially, asynchronous sort of fire and forget.
Yes, because in those environments, for example, you have to work with timeouts because you need to say, how long do I wait for the response? So it's more natural there.
It is more natural. And the sort of shock absorbing characteristics of the message queues allow you to decouple the operational availability of the sender and receiver.
Right. Yeah. Anything else I forgot to ask in the stability area? Anything else you want to say there?
The last one that I would offer is the one that the stability pattern I call fail fast. We very often build systems that aren't very aware of themselves. They don't know how well they're performing. They don't know what their internal state is. They sort of blindly attempt to do the processing for whatever the request is, and sometimes do quite a bit of work before ultimately failing. And that can be, an application level failure like bad input parameters, or it can be a system level failure like I can't talk to the database right now, it's been hit by a meteor. So fail fast is my argument to say, as soon as you receive a request for work, check your own performance against SLA. If you have a 2-second response time and you're monitoring yourself at 4 seconds or 10 or 30 seconds, it's better to simply say immediately, I cannot do this work. Likewise, you can check the state of your circuit breakers, resource pools, etc., and say, I cannot do this work right now.
It's better than trying to meet an SLA deadline that's already passed.
Right.
Okay. Second overall 10,000 foot aspect is capacity. And again, I think it makes sense to introduce what you mean by that, especially since you distinguish it from scalability or performance.
So in terms of capacity, what I'm regarding as capacity is the ability to perform a certain workload mix within an acceptable response time. So this has a relationship to performance, in that the better the application performs, the easier it is to maintain or sustain a workload. And it also crucially involves the workload mix. So, I've seen many times in retail or insurance or hospitality applications, some types of users are very cheap to service and some are very expensive. Usually the ones that are expensive to service are the ones who do things that make you money, like buying things, reserving hotel rooms and such. So the mix of workload is significant when we talk about capacity. In this section, I'm trying to help maximize the capacity that we can get out of an existing set of resources.
Right.
And so this is about ways to look at the code itself and some of the design characteristics to get as much capacity as possible.
Okay, so let's look at some of the things that then can go wrong. And they are a little bit, some of them are a little bit technology specific, right? So maybe we should focus on those that are not necessarily Java specific, although of course that's a little bit the background of your book. Right?
There's some of both, yeah. My book addresses Java and .NET, and generally speaking, any kind of online system.
Right.
But most of my examples are in Java because that's where I've worked and collected them. So the ones that are fairly general, one that has a deleterious effect that most people don't appreciate the full magnitude of is contention for resources in a resource pool. And so we always create resource pools as a way to sort of cache those back-end connections so we don't have to make a new connection on every request. But it turns out when you have more concurrent requests coming than you have things in your resource pool, the degradation is quite sharp and it accelerates quite rapidly. And it gets geometrically worse when you introduce multiple resource pools. So if a thread has to check out connections from 2 different resource pools, then it's likely to encounter contention on both. And there's a feedback effect because when it encounters contention on both, that lengthens the processing time of that thread, which means it's holding resources for longer, thus increasing the likelihood of further contention.
Right. Yeah. Positive feedback. Another one I actually find funny is Ajax overkill, since I'm a little bit of a Web 2.0 skeptic, or I kind of dislike the hype. This plays very nicely into my agenda, kind of. So what's that?
Well, so I had initially titled that section Ajax. But as I looked into it, I discovered that Ajax can be used for the good or for the ill of the backend system. Where it's used for the ill, you see things like polling on keystrokes to do auto completion of fields and things like that, which adds relatively little value, but vastly increases the number of transactions that the backend has to process. And so you have the TCP setup time, you have thread checkout time, all the overhead incurred for what might be just a tiny amount of actual functional work. And it's that overhead that concerns me.
Okay, makes sense. Another one that I think is interesting is handcrafted SQL. Is that your experience that people don't really understand SQL and therefore create queries that are kind of ineffective or inefficient, or what's the point here?
Far beyond ineffective, they create queries that are downright horrifying. We have very good OR tools these days. And all of them have this escape hatch that lets you create your own SQL and submit it directly. And sort of because we've got good OR tools, the handcrafted SQL tends to be stuff that's already hairy and difficult. It's already sort of outside of the normal realm of things that you should do.
Otherwise the OR mapper could do it.
Exactly. So you see things like 8-way unions, where every clause of the union has a 4-table join in it. I see a lot of things like that where somebody has tried to say, Databases are really good at this type of work, so I'm going to make sure I push as much of it into the database as possible. And so they create this, several page SQL thing. I just had one emailed to me last night, in fact, that was utterly ridiculous. I couldn't find a font size that would show me the whole thing.
Yeah. So what do you do there? I mean, do you load the data and then do the computation in memory, or is it about denormalization and keeping the denormalized tables kind of in sync? Or
well, in almost every case, I find that the handcrafted SQL tells me that there's some missing abstraction. There's something that's not being represented in the database or as objects or in memory that ought to be. And so usually the first thing I do is try to tease out what the true underlying abstraction is, and see if there's a way to reify that in the object layer or in the database layer.
Another one that kind of to sum this up, which has a funny title, is Cookie Monsters. I just imagine the big monster next to the big table of cookies.
Yeah, exactly. Well, part of trying to name patterns is to find names that people will remember have concrete images.
Absolutely, yeah.
So the Cookie Monster is a site which abuses cookies and tries to put too much data in them. So I've seen this even recently, where a retailer was trying to create a persistent shopping cart. So you could add some things, go away for a month, and when you came back, your cart would still have the things in it, on the premise that you actually, expect to buy everything that you put in your cart.
Sure.
And they were doing this by taking the shopping cart object, serializing it, UU encoding it, and putting it in a cookie.
Mm-hmm.
The cookie was sometimes exceeding 4K in length, so some proxy servers would cut it off. Some browsers wouldn't handle it well. And if you think about the way that the cookies get sent, they get sent on every request to that domain, whether you need it for that or not. So even once the cart was deserialized, this 4K chunk was being sent down and up on every request. Yeah. That adds time and processing and memory and so on.
Yeah. And of course, the right way to work with cookies is to put an index into them and put the data in the database and garbage collected at that time. Capacity patterns, what's the positive stuff you can do? First one you mentioned is pool connections. That's kind of obvious, right? I mean, everybody does that. So there must be something more to that, how to do it right, or I don't know.
Well, not necessarily. I mean, sometimes we document patterns because they're commonly done, not because they're new or unique.
Right.
Pooling connections is obviously important. We do it to the database all the time. We do it somewhat less often when we're communicating with other enterprise systems, but it's worth doing there as well.
Right. The other one is use caching carefully, which I find is an interesting name because it suggests that caching is good because you should use it, but then it says carefully. So there must be a trade-off.
There is. In fact, at various times as I was writing the book, caching appeared as an anti-pattern, as a pattern, or even both.
Yeah.
And that's because it can be both. So we add caches to speed up response times and avoid traffic to the database.
Yep.
And yet, most application servers, they don't get CPU bound. They are typically memory bound. And so when traffic gets heavy, it's memory that gets short first. And at that point, this large cache that we've got that's supposed to be speeding things up increases stress on garbage collection and therefore slows down the whole system.
Right.
So I definitely believe in using caching, but I believe that the caches should be elastic.
Right.
They should be willing to give up space when memory gets tight. And we can do this through language features that make the
weak references,
soft references, those things that make the garbage collector people cringe.
Yeah.
Kirk Pepperdine was covering his face when I was talking about soft references in my talk yesterday. So we can make the caches elastic, and that certainly helps. The most common kind of cache is just a hash map, which gives us no ability to limit size and no ability to gracefully release memory as we need to. So I think we need to move away from that.
And have maybe at least a wrapper around the hash map that keeps track of the amount of stuff in it and then don't accept anymore.
And yes. A very interesting development that's come up since I wrote the book is the use of cache servers and cache farms. Memcache. You can use gigaspaces that way. You can use Coherence or Terracotta that way.
Yeah.
These, I think, are a very significant development.
So what do they do?
Well, a cache server is essentially just a big bunch of RAM with a socket in front of it. And you can put things into it and you can get things out of that.
Mm-hmm.
Different ones have different levels of capability around distributed replication
yeah.
and so on. But in essence, what they allow you to do is pull all of that memory out of the JVM and offload it to another box that may be nothing but a huge amount of RAM.
Mm-hmm.
We're hearing people say RAM is the new disk and disk is the new tape.
Yeah, right. Yeah, there's also this thing. I think it's called relayer or delay or something. There is a tool in Java that, there are people who say forget databases, put everything in memory, dump it in the evening, and if it crashes, you have a failover machine. Mm-hmm. That's kind of the same tendency.
Right. Yeah. The use of RAM for long-term storage.
Yeah, and I mean, you can buy a couple of gigabytes for cheap money, and not everybody has a gigabyte database, right? So it's kind of realistic.
In fact, there are vendors now who are selling caching appliances,
mm-hmm.
which are just 1U pizza boxes stuffed with half a terabyte of RAM.
Yeah.
Half a terabyte of RAM.
Yeah,
I mean, it's kind of a staggering amount.
Yeah.
The other benefit that these offer, though, is an efficiency one in terms of redundancy.
Yeah.
So if you think about caching, say, all of the hotels in your hotel chain, you might cache those in memory in the JVM. If you're in a horizontally scaled application server farm, then you're caching that entire list, n times, where n is the number of instances that you're running. That seems a little redundant, right? I'm essentially chewing up 300 meg of heap 20 or 30 times.
Yeah. Well, but if you have it in a central shared location, there is more overhead to access it, right?
There is. You do give up a little bit of latency.
Yeah.
But in giving up that latency, you're gaining a lot of capacity.
Right. Yeah. By the way, that's a trade-off that you have to do quite often. In order to get better overall capacity, you have to maybe reduce the efficiency of each single specific action or whatever it is.
Absolutely. I completely agree.
Yeah. Anything else you want to mention on capacity before we move on to the next one?
One more that I would offer is about pre-computing content.
Mm-hmm.
We have this tendency, when we're talking with our users, the people who create content for our systems or change prices or feed the data into the system, we have this tendency to set an expectation that their changes are instantly visible everywhere in the world. And we build things that way.
Mm-hmm.
So we build pages dynamically on every request. But we often don't need to do that.
Right.
So, for instance, I saw a site where they had a sort of category navigation structure. Tabs across the top. When you hover over the tab, you see subcategories listed underneath it.
Yep.
Those subcategories can change. So they were querying the database every time to build that category tree.
Yeah. But they change only once a month.
Tree that you're pulling out of a relational database. So it's 8,000 queries on every single page to build the menu.
Yeah.
The thing is, we know exactly when it changes.
Yeah.
There's a content tool that publishes those changes.
Yeah.
It's not as if, we could be caught unaware that the categories have changed.
Yeah.
And so I like to look at the number of times something changes versus the number of times it's being viewed.
Yep.
And in a case like this, the things were being viewed literally sometimes nearly 1 billion times for every time that they were changing.
Yeah.
It makes no sense to build it dynamically every time.
Right.
We're much better off pre-computing that content and publishing the content and just spooling it out over the wire.
It's a little bit related to this thing we talked about before where I mentioned the intentional denormalization, because that's basically pre-computing content in the database layer.
Exactly right.
And then there is this other thing where a while ago, actually, I think 3 years ago or something, or 2 years, I talked to Werner Vogels about Amazon stuff.
Mm-hmm.
And he said that one of the pillars of building large distributed systems is to defer the consistency, to basically give up some consistency, some real-timey behavior in order to make it more scalable. And that's also something in that space.
Yes, it is, and that's also an area where there's been a lot of very interesting developments over the last couple of years. Maybe will be for the next book.
Yeah. Okay. Let me know.
No promises.
Next topic is operations. Again, you're today working mainly as an operator, so meaning as somebody who operates software in the operations department. Why don't you give us a little bit of an overview of what people can do right, what they can do wrong to make your life harder or easier, simpler?
Sure. What I found is a lot of software is failure-inducing. That is, it provokes the operators into doing the wrong thing.
Uh-huh.
And I have an example from one of my own systems where I found that operations had instituted a regime of restarts, recycling the application servers whenever they saw a message that said maximum entropy limit reached, channel reset required.
Mm-hmm.
One time, they had observed that message in the log file immediately prior to a system crash.
Okay.
And so they formed the superstitious belief that that message indicated the crash. It was coincidental, but they instituted monitoring and automated response that would restart anytime they saw that message.
Mm-hmm.
Well, I was horrified because I had written that message, and it had nothing at all to do with resetting the server.
Yeah.
It was just talking about resetting the crypto key for a communication channel.
Yeah.
I recently read Schneier's excellent book on implementing that sort of thing.
Right.
So what I came to realize is that we very often log messages that we intend for ourselves, for developers. But in fact, the audience of log files is operations.
Well, the audience of some of the log files, because you can also use log files for tracing bugs.
You can, yeah. So anything that's logged as error, severe, warning, or info, that is for operations.
Okay, yeah.
And so we need to be cognizant of how we write the messages, so that we don't encourage them to do the wrong thing, especially because we often don't deliver a complete list of all the messages that our applications can produce.
Yeah.
I mean, I've been asked for that many times, and I always fight back, even though I know how useful it is to receive one.
Yeah. Yeah. But, I mean, logging generally is a good thing, right? I mean, it's necessary for the operations folks to be able to understand the system.
Absolutely. In fact, logging remains the primary tool that operations uses to understand the system.
Right. And then, of course, they have monitors that log the log output stream and define rules of what to do when something occurs.
Exactly.
Yeah. So it's also important that the log is structured well enough so that you can define automated rules that do something with it.
Yes. In fact, one of the things that I advocate is creating message codes.
Right. Yeah.
And this is something that was always there in the mainframe days and kind of disappeared in the OO world today.
Yeah. Yeah.
And I have a section in the book that offers a good trick on how you can create message codes very easily and produce that reference document of every message that the application can produce.
Probably about hashing the error message or something.
No, it's using the internationalization tools to extract all the strings.
Mm-hmm. Okay. Mm-hmm. Okay. Another thing that I think is interesting is I should ask the question the other way around. How important is it that your system provides hooks for various management tools? The various IP-based protocols that are defined, or Java management API or something.
So it used to be that SNMP was the thing that we aimed for.
Yeah.
And I've experimented with creating custom MIBs for my applications so that they could be, the MIB is a definition of all the variables and tables that are exposed through the management layer.
It's kind of an interface definition of how the monitoring tool accesses your system.
Yes, exactly.
Yeah.
So I've experimented with that, but what I found is operations people will never accept a custom MIB from the development group.
Okay.
Not ever. They're very protective of their monitoring system, as they should be, because if anything happens to that, they are blind.
Yeah.
So that turns out not to be a very profitable approach. But for anyone working in the Java world, JMX is certainly valuable. And exposing the state of your application through JMX is something that I strongly advocate. It is possible also to get JMX to SNMP bridges and adapters. So if you're exposing through JMX, then you also have the ability to expose through SNMP.
Right. Anything else on operations that you want to mention here?
One thing that I do have to bring up is sort of a hot topic of mine, or a rant of mine, relates to configuration files. So I've done a lot of work with things like Spring, where we've externalized configuration into what's sometimes a very large file. And we deliver that file inside of our application itself, so inside the WAR file or inside the EAR file. That configuration file has a number of drawbacks. One, it's extremely sensitive to syntax. So if a non-programmer gets in there and removes a single quote character or misplaces a single right bracket, the entire file breaks. Second, it mixes together the essential plumbing of the application with configurable parameters that administrators should change.
I was actually about to protest when you said configuration file in the context of Spring, because the beans XML isn't really what I would call a configuration file for exactly that reason, because it's application wiring as opposed to parameterizing whatever queue sizes and stuff.
Well, but it mixes all of it together in a single file.
And that's a problem.
For Spring, fortunately, there is a thing called the property override configurer, which lets you create an external file that overrides individual properties of individual beans. This has several benefits. First of all, it lets you create a file that's more robust. It's just name equals value pairs. It lets you create a file that lives someplace else. So it's not overwritten with every deployment. It doesn't have to be hand edited every time you do a new release. And it lets the administrators keep control of things like production database passwords that have to be treated with the highest level of security these days.
I guess it's really useful to see this trend towards XML instead of source code is, I'm not sure if I like it, but clearly there are some parts of XML-based specifications like XAML, right, the UI thing, or also Spring Beans XML that is effectively source code and not a configuration file. You need to separate those, and that's basically just what you said.
Yes, I completely agree.
Okay, so we've stepped through the three main topics. There is also a bunch of, let's say, general issues that didn't fit into one of those categories. Is there anything you want to mention from those that are kind of worth highlighting? Of course, we want to tell people all buy the book, but...
Well, so the general design issues section did end up as sort of a holding place for topics that are important to creating production-ready software that don't fit the structure anywhere else. So one of them, for example, is about the way we open sockets. Every textbook and every tutorial on opening sockets is wrong. It's simply wrong.
Why? You mean server or client sockets?
Server.
Okay.
The reason being, a server in a data center today has more than one network interface. It always will. Typically, you'll have two for production traffic, and these may be teamed or they may go to entirely different switches. And then you'll often also see management interfaces and backup interfaces that have their own IP addresses and they're on separate networks. And yet when you open a socket and you don't specify which interface you're opening it on, if you only open a socket with a port number, you're listening on all of them, which is rarely what you want to do. Because the security structure of the back-end networks is often much flatter than the security structure of the front-end network. So I've seen order management systems with ports that you could send XML into for orders. And the order management system would trust the pricing that the front end was trying to send to it. And yet it listened on all of the interfaces, including the flat backup network. So anyone who had any access to any machine backed up over the network could connect to this socket and submit orders just by using Netcat or something like that to send a chunk of XML.
Certainly not what you want.
Clearly not the intended behavior.
You have a like mini section on security, right? I mean, I guess getting security right is also a challenge that's bigger than most of us developers probably think.
It is bigger. And I don't give security a full treatment,
Yeah.
but I do address, some of the very basics.
Yeah.
For instance, please don't write any more applications that have to run as root.
Yeah. So the last thing I want to briefly mention is this thing about load balancing and clustering. Yesterday I did an interview with Owen Woods, and he said that one of the top 10 architectural mistakes is that people think they can build their own clusters quickly. We can do it better than WebSphere. So I guess one of the recommendations here is probably not to do this.
In fact, I never imagined that people actually would try to build their own clustering software.
Yeah. Well, it's not really clustering, but replication and failover and stuff instead of using what the servers come with.
No, I definitely would advocate using the well-proven and tested infrastructure from the application vendors.
Yeah.
So I talk about both being part of a cluster and using clustered resources.
Right.
So, for instance, if your application calls a database, which is in any sort of an active-passive failover cluster, unexpected things may happen when the cluster fails over. So, for instance, the virtual IP address may be handed off to the passive node as it's becoming active. Your application may not be aware that the IP address now belongs to somebody else.
Yep.
And you typically don't have stateful failover of all the connections.
Yep.
So the database connection you've been using just fine all along suddenly stops working altogether.
Yeah. Or magically has different stuff in the database because it wasn't replicated in time.
That is possible too.
Okay, so I guess this brings us to the end of the discussion, and I don't know if there's a podcast called The Space Show, and the guy who runs the podcast always asks his guests at the end of the show whether they have any pearls of wisdom that the guest wants to leave with the listeners. So I've kind of made it a habit to also ask this. Is there anything you want to leave our listeners with, except, of course, they should buy the book and read the details?
Well, I'd like to think I put all of my wisdom into the book. But the one thing I would leave your listeners with is this. It's my plea, really, to consider the entire life cycle of the project and not to take shortcuts during development to save a one-time development cost at the expense of an ongoing operational cost.
Right. Yeah. Well, you shouldn't reply here, but I mean, of course, if you have different budgets and the development guys don't care about the other ones, this can be a hard sell.
That can be an organizational problem.
Yeah.
Yes. Debugging those is outside the scope of my book.
Okay. That's a nice closing word. Thanks for being on the show.
Thank you.
Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the PodSafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.